Hello everyone, welcome to this channel. This question is from Olympiad Pathfinder, Chapter 12, Build Your Understanding, question number 2. The question is, one end of an insulating rigid rod of negligible mass and length L is pivoted to a fixed point O. A small ball of mass having a negative charge of modulus Q is attached to the lower end of the rod. Another small ball carrying a positive charge Q is fixed at a height h above the point O as shown in the figure. What should the range of values of mass m of the lower ball be so that the rod remains in a state of stable equilibrium? Acceleration due to gravity is g. Let us solve this question. This rod is massless and it has a length L that is given in the question. It is pivoted at O point. Small ball of mass m here and negative charge minus Q is attached here. Another small ball of charge Q, capital Q, is placed at a height h above above O point. For this ball to be in stable equilibrium, we must shift this ball with a small angle theta and study the motion of it. This angle is theta. It's very small. For the purpose of showing, it has been shown in laws. So it is basically the magnified version. So if this is the angle theta, we have assumed that this angle is alpha. So from this triangle, if this angle is alpha, so this angle should be theta minus alpha. This has further been magnified here and shown for the convenience. Like this angle is theta. So for this triangle, these are the two remote angles. So sum of these should be theta. So this angle is alpha. So this angle should be theta minus alpha. The rod length is L, that we know. So this will be L sine theta. And this will be L cos theta minus alpha. From this triangle, AC will be H cos alpha. Three forces are acting on this ball. One is the gravitational pull. Other is the electrostatic force in this direction. And one, the tension force along the negligible mass rod. So if this ball was at stable equilibrium here, so when this ball has been shifted here and released, it should come back here. For that to happen, we will study the moment of this ball with respect to O point. So what is the moment of mg with respect to O point will be mg into perpendicular distance L sine theta, and this is in clockwise direction. This force is acting in this direction, so perpendicular distance to that force is OC. So this is having a moment in anti-clockwise direction, and the magnitude will be Fe force into the perpendicular distance, that is H sine alpha. Since we are taking all the moment about point O, so T is having no moment arm on it, so there will be no moment for this force T. As we said that this ball to be in stable equilibrium at this point, this must move back to this position. So it means the clockwise moment should be greater than the anti-clockwise moment. So we can write this equation: mgl sine theta is greater than Fe into H sine alpha. Let us say this equation 1. Now electrostatic force, we can write for the equation for that is K into Q divided by H cos alpha plus L cos theta minus alpha. This is in bracket whole square, that we know from the formula. This K is equal to 1 by 4 pi epsilon. Since theta is very small, alpha will be further smaller. So therefore cos alpha and cos theta minus alpha, we can take it, will be very close to 1. So we can take it as 1. So this equation will reduce to this number 2 equation. From triangle AOC and triangle BOC, OC will be H sine alpha from AOC, and from BOC it will be L into sine theta minus alpha. Now again alpha and theta minus alpha is very small, so we can replace sine alpha by alpha and sine theta minus alpha by theta minus alpha. So we will get this equation: theta is equal to H plus L in bracket into alpha divided by L. Now from equation 1 in the previous page, 2 and 3, this was the equation. We will put all the value. Sine theta, again theta is very small, so we can replace sine theta with theta radians. Fe into H sine alpha is further small, so we can replace sine alpha by alpha. So we will be getting mgl into theta will be greater than electrostatic force into H into alpha. We will put the electrostatic force from this equation. So we will be getting this. Upon solving, we will be getting m should be greater than k into q into small q h divided by g into h plus l q. K we will be replacing with 1 by 4 pi epsilon naught. So our answer should be m should be greater than 1 by 4 pi epsilon naught, capital Q into H divided by G, H plus L in bracket to the power Q. This is your answer. So the whole concept is that it's the mass to be in stable equilibrium, since it is pivoted at one point. The moment when we shift the ball, should bring it back to that position. And that is the reason we had written this equation for you and solved it. So hopefully you understood the concept. Any difficulty in understanding, please do write in the comment box. I will come back on that. Thank you.